Right. Um, Hello everyone. I wanted to make a video with a hint and some cool animations about the problem about the shadows. I have this Desmos animation, which I'm pretty excited about. I think it's pretty cool. And what is meant, this is representing is this pink or purple thing here is representing our person. And our person is walking away from a lamppost, and you can imagine the lamppost is up here. And as they're walking away, well, they're getting further from the lamppost, and their shadow, which of course the shadow, the way that works is it is where the light from the lamp will come down and hit their head, and then project their head down here onto the shadow. And as time goes on, well, the shadow is getting longer and longer and longer. That's really cool. And we can sort of ask, well, if the person is walking at a certain speed, well, how fast is the shadow changing? And then what about the tip of the shadow? How is that moving? Are these the same question or are these different questions? Well, let's see. So I'll include a link to this so you can play around. In fact, if you want to look at the code, you can try and figure out how I did this. This is super fun. So let's take a look here. So if we watch this, you can see I've color-coded things. We've got this purple stuff down here, which represents how the person is walking. If we think about the tip of the shadow, well, that's going to be this thing here. Actually, that should be red. Let me go ahead and change that so that we don't get confused there. Okay, perfect. That's red now. And so if we look at this, we've got the tip of the shadow here that represents this red distance here. It's getting bigger and bigger and bigger. And then we've got this black distance down here. Now the black distance is the length of the shadow, right? So I've sort of moved it so that they're all sort of starting at the same point. And the reason I've done that is because you can see they're all growing at 3 different rates. All right, we've got the purple rate, that's the person. We've got the shadow rate, that's the black one at the bottom. And then we've got the red, which is the tip of the shadow. And we can see that that one's plodding along as much faster than all the others. And so in this problem, we're supposed to figure out if our person is walking at 4 feet per second, then how quickly is the tip of the shadow moving? So this is a related rates problem. And what I encourage you to do is to maybe take a look at this video and see, well, we're given information about our person moving. Is that information about this distance x, about this distance s, as in shadow, or this distance y, which measures the distance from 0 all the way out to the tip of that shadow? So what are we given, and what do we want? So that's the first question. In fact, you might want to pause the video here and try to think about that and come up with a plan. And then the next step in all of this is to think about how we can find a relationship between our 3 letters, X, S, and Y. One, I bet that you see right away, is that X plus S is going to equal Y. That's pretty clear how we've set it up. But there's another relationship that we have too, which comes from the fact that there is a big triangle. Let me trace it out here. It's a big, huge triangle, and this small triangle in here. So those two things, those 2 triangles are what are called similar triangles because they have the same 3 angles. I'll let you think about why they have the same 3 angles, but what's cool about this fact is that when you have 2 triangles that are similar, we can take the ratio of any 2 of the sides and we'll always get the same answer. So for instance, in this small triangle, the left side over the bottom side is 4/3. And so if we did that ratio in the bigger triangle, we should also get the same ratio. So for instance, we scaled this triangle by a factor of 3 to go from 3 to 9. So that means that this 4 should become a 12. Right? In the next example, maybe we have a picture. This looks a lot like what we have here. In this case, we see that if we were to say divide x over 2, so that's the height of the triangle by the base, that should be the same as dividing 1 by 3, right? So the height over the base should be the same for both of these triangles. So x over 2 should be the same as 1 over 3. Let's do a couple more. This is kind of like the one we saw earlier. 3 over 4 is the same as 6 over 8. And then finally, here's one. Maybe we could check that 8 over 6 is the same as 4 over 3. And x over 4 should be the same as 3 over 6. Right, so we get all of these relationships in our triangles. And our job, well, your job on the homework is to work out some equations. You should get some equations relating x, y, and s. And yeah, and hopefully you've got a goal written down, what you're looking for, and you can use the information in this problem to solve for that. So as always, email with any questions, link to the Desmos in the description. Thanks for watching. Bye.